Okay, so we're moving from the thoughts of the ocean to the Underground Physics Laboratory in Stawell. Professor Virginia Kilborn is our next speaker, is Swinburne's inaugural chief scientist, has a background in radiochemistry, works closely with the Centre for Astrophysics and Supercomputing at Swinburne University, and is a leader in the astrophysics community, past president of the Astronomical Society of Australia and current chair of the National Committee for Astronomy for the Australian Academy of Science. So welcome, Virginia.
Thank you very much, and yes, it's really great to meet you all here today. Thank you so much for the introduction. Yes, I'm Swinburne's chief scientist, and I think the only chief scientist at the university, so very lucky to have that role. And at Swinburne, I just mentioned that our Vice-Chancellor, Professor Pascale Cuesta, she's French. She's got a very enlightened and different view on nuclear to a lot of the discussions that we have in Australia, and so it's a big joy to work under her leadership. But I'm not here to talk about Swinburne. I'm here in my role as Deputy Chair of the Stawell Underground Physics Lab, which is a brand new facility which is government funded and is just about to start operations. And I'm going to give you a little bit of a tour of the underground facility and maybe spark your interest in how you might be able to use this facility in the future. So firstly, what is an underground lab and why would you want an underground lab? And there's a number of underground labs around the world, actually. There's Sanford in the US, there's Gran Sasso in Italy, there's another facility in England. And all of these facilities are located deep underground, or in the case of Gran Sasso, within a mountain. And the reason for that is that it is to have a really low radiation environment. And by low radiation, I mean cosmic radiation, so radiation particularly charged particles from the sun. And so if you're trying to do fundamental experiments, you might want to do it without having that cosmic radiation. And that's what these facilities enable. So we've got a really stable facility. The temperature's very stable, the ground's reasonably stable, especially in Australia. And that allows for these fundamental science experiments. Our foundation experiment, I'll explain in a minute, is about dark matter. But we're also looking at things like particle, quantum and nuclear, and also biological and other experiments that we might be able to conduct down in this lab. There's obviously potential commercial applications, defence applications, and partnerships that we're looking to form. And the beauty is this is the I think it's the only at the moment Southern Hemisphere underground lab facility. And when you're talking about fundamental physics experiments, especially cosmological experiments where we're trying to detect dark matter, it's really important that we have that north and south facility to be able to confirm the results. So now I'm going to take you on a bit of a tour of the facility and a bit of the history of it, so you get a good feel for it. So the facility is located in Stawell in Victoria. You may not have gone there unless you really like running. There's the Stawell Gift, and so you can go there, and if you're very fast, you can win. Or if you like climbing mountains, the Grampians are nearby Stawell, so you might have driven through Stawell to get to the Grampians in Victoria. Beautiful spot, highly recommend. Stawell is a gold mining town, and you can tell by the sort of beautiful old buildings in the town, around Australia, where you're going to a little town which has, a few thousand people, but they've got buildings to the max. You know that it's been a gold mining town, so Stawell is one of these. And that's a little hint as to why this is located in Stawell. So our lab is located within the operating Stawell Gold Mine, and this is a beautiful image of the Stawell Gold Mine here. So the Stawell Gold Mine is a working gold mine, and the tunnel in which our lab is located is not currently being mined, thank goodness, but there are other active mining areas connected to it. So when you're driving down the decline, it actually reminded me a little bit of when I came in on the cab last night and you're going under the tunnels under Sydney Harbour. It's a bit like that, but imagine it's smaller with just dirt on the ground and dirt above, and then 50-tonne trucks coming towards you, bringing out the gold. That is really what you're sort of getting to when you're going down to this lab. So it's 8 kilometres of tunnels, and then you get to the lab. And if you can look closely, this is the, I don't know if you can see you can't see my cursor, but never mind. You can see where the blue arrow is. That shows you the entrance to the mine there. So why in this particular mine? And in 2014, it looked like this mine was going to close, and there were some scientists at Swinburne and Melbourne Uni who went, well, there's a big hole in the ground. We'd like to detect dark matter. Maybe we can use this mine to detect our dark matter. And so they actually rang the, there's a funny story related to that, but maybe I won't say it. But sorry, but they rang up the local councillor and the mayor and said, look, I understand you have a big hole in the ground here. We'd like to use it. What do you think? And the town absolutely embraced this. They were very excited, and we were able to get both state government and federal funding to the tune of a bit over $10 million to be able to build the facility. So you can see in these images that really did start just as no hole in the ground, then they've sort of excavated it out. The people are there for scale. It's about 3 stories tall, and you can see one of the mining trucks there. So one of those, really important relationships with the mine, and subsequently the mine ended up being taken over by a consortium, and so it continued operating. But in the meantime, the construction of the mine actually gave a lot of the miners jobs and job security and an ongoing purpose for that mine. And so the local community is 100% behind this facility, which is absolutely fantastic. So as I said, here's a couple of the tunnels as you go down, and that little door on the right there, you can see through the car window, is the entrance to the mine. A little bit like the TARDIS, you walk in there and you're greeted with this. And so it's really hard to explain in pictures and words the feeling of sort of going down narrow tunnels. It takes about half an hour of driving to get down there. At one point you meet the east-west tunnel, which is where the mining stops, and then you keep going for about 20 minutes. You're the only ones down underground, and then you open the doors up and you're in this massive facility. So really, really exciting. As you can see, the facility is actually now finished. It's signed off, and we're starting radiation testing at the moment, and we'll be installing our first experiments in the next month or so. Here's a, what do you call that, schematic, I guess, of the lab itself. Where you can see we have the main room of the lab, and then a number of smaller rooms where we've just got room for equipment and that sort of thing. As it is a working mine, safety is absolutely paramount. You have to go through an induction, wear a breathing monitor. We have an escape pod just outside the mine if needed, and so access to getting down into the lab is really restricted to those who absolutely need to go. But having said that, installing your experiment is an absolute need to go, and so we do really want to encourage people to think about using this as a facility. So now I'm just going to, as you heard, my background is astrophysics, although when I was at high school I thought I'd be a nuclear scientist, so sorry, something went wrong along the way there. But happy to be here today, but I'll go back to the roots of why we've actually, got that impetus to build this lab, and it's this dark matter detection. So in Gran Sasso, they have had an experiment called SABRE, sodium iodide with active background rejection experiment, and that is trying to detect dark matter which we think might be weakly interacting particles, or WIMPs. Massive particles should be in there, sorry. And that's one of the possibilities. So we think that these WIMPs will interact with the sodium iodide. They will then give us a signal, and then we'll be able to detect the dark matter. But in Gran Sasso, they have a potential detection, but what we really need is that southern equivalent to confirm it. And that's really the impetus behind this lab, although there's so many other uses that we can use it for. Just to show you what the experiment actually looks like, behind these people you'll see what looks like a tank. It is actually a tank, and it's going to have these detectors in there that that's highlighted in the middle, which will then scintillate. They'll sort of we're going to have 8 sodium iodide crystals, very pure crystals. We think the WIMPs are going to interact with the sodium iodide crystals, give off a bit of light. That's going to be detected then by these detectors within the tank. And that tank is currently at Swinburne. It was built at Swinburne. We're going to have to put it on the back of a truck and fill it up with a particular liquid and then take it down into the mine. That's going to be an achievement in itself, but then it'll be another, multiple years until we really get the equipment up and running. But as you can see in the schematic on the right, that particular experiment only takes up a very small part of the very large space that we have there. And so that's where you guys come in. So we're thinking of what experiments can we do in this lab that are going to be of use to Australians. And when you look at what's happening in, say, the other underground labs overseas, there's geological experiments, biological experiments. Obviously, there's actually quite a lot of dark matter experiments. Quantum, there's a really interesting experiment about trying to do error-free quantum computing, so you don't have the interference from the cosmic radiation. And what about your ideas? And so it might be fundamental nuclear physics, or maybe it's radiation testing. So we have to actually do really strict radiation testing within this facility. I'm really keen to hear of people, I'm pretty sure this audience would have a good idea about radiation testing. So, maybe there's partnerships that we can think of there. The chair of the board, Dr. Sue Barrell, said to me, come to the conference and see if anyone wants to invest. I'm not sure if you do, but we are always interested if you would like to become a partner or investor. But really what we would like is this to be a working facility with lots of experiments that are going on, just telling us about the way the world works. So I'm going to just tell you a little bit about SUPL itself, so you understand the mechanics of it. So SUPL, this Stawell Underground Physics Lab, is a company limited by guarantee, and that operates the underground lab. But we have a really complex array of partners. So we had our initial funding from the Commonwealth and Victorian state governments. We have our founding partners, and they've also put in funding. We have our research users. Our first research user, of course, is SABRE, and that's an experiment coming out of the University of Melbourne and 5 other universities. And then, of course, we have that really important relationship with the gold mine, who is our operational partner. They're absolutely fantastic partners. They, provide the power, the water, the safety, and they are 100% behind us all the way. So we've got all of these sort of coming together to run this brand new facility. And so I think this is like the really exciting stage for us, that we've done all the preparation work, all the safety work, ticking all the boxes, and now we're sort of getting into the experiments. Our partners, we've got 5 universities: Adelaide, ANU, Melbourne, Swinburne. Oh, that's 4 universities. Sorry, and AINSE, who are our main partners. Obviously, we've got our supporters, the Stawell Gold Mines and the Northern Grampians Shire Council, which we can't thank enough for their support, Australian Government, Victorian Government. And then our research partners, the Dark Matter Centre of Excellence, who is running the SABRE experiment, and of course Gran Sasso, who is running the Northern SABRE experiment. The board of directors is here. Just for your interest, please reach out to the board if you've got any questions. We've actually just had a change. Professor Liz Sonnenberg has left the board, and we've got Professor Michaeli Trenti from Melbourne Uni. But on the board is a member from each of the universities. So I'm Swinburne's representative. We have Tim from ANU, Michaeli, not Liz, now from Melbourne Uni. And then we have Virginia Deegan from Adelaide. Professor Andrew Peel, who runs the synchrotron in Melbourne, is on for ANSTO, and ably chaired by Dr. Sue Barrell, who was the previous chief scientist at the Bureau of Meteorology and a force to be reckoned with. So, challenges and opportunities. The opportunities are that this is a highly valued enterprise by the mine and the local community. We're looking at how can we use this to enhance outreach and education in rural areas and also internationally. It's unique infrastructure for Australia and for the Southern Hemisphere. And then we've got some challenges. So we have the agreement between the mine and SUPL to have access and compliance. It's highly regulated, obviously conscious of the working environment and access. And of course that operational funding, which we're really working on the business case at the moment to make sure that this is an ongoing concern. So that's where I want to leave it, but just to say, I think you get a copy of these slides. There's some resources there that you'll be able to use. And please reach out to me or Sue if you've got any ideas for experiments. Thank you so much for having me.